So welcome you all on this YouTube channel. So this question is based on DC machines. It has already been asked in ESE 2020 examination. Question is like a 4-pole DC motor is lap wound with 400 conductors. 400 armature conductors. The pole shoe is 20 centimeter long and the average flux density over one pole pitch is 0.4 Tesla is 0.4 Tesla, right? The armature diameter is 30 centimeter. Now when the motor is drawing 25 ampere and running at 1500 rpm, then what will be the torque developed by the motor? So that's a question. So out of ABCD, out of these four given options, only one option is correct that we have to find out after solving the numerical. So I repeat the question. A 4-pole DC motor is lap wound with 400 armature conductors. The pole shoe is 20 centimeter long and the average flux density over one pole pitch is 0.4 Tesla. The armature diameter is 30 centimeter. When the motor is drawing 25 ampere and running at 1500 rpm, then what will be the torque developed? So first of all, let us note down the given values. So it is a 4-pole DC motor, so number of poles are given as P is equal to 4 and it is lap connected. So for lap connected armature, we know that number of poles is equal to number of parallel paths. So parallel paths are represented by a letter capital A. Poles are represented by a letter capital P. So P is equal to A. For lap connection, both are equal. So P is equal to A is equal to 4. Now there are 400 armature conductors. So number of armature conductors are represented by a letter Z and Z is equal to 400. It is given in the question, right? Now the pole shoe is 20 centimeter long, so length is given as 20 centimeter and the average flux density over one pole pitch is 0.4 Tesla. So flux density is given as 0.4 Tesla. Tesla is Weber per meter square, right? Weber per meter square is equal to Tesla. Tesla is equal to Weber per meter square. Both are one and the same. So now the armature diameter is 30 centimeter. Diameter of the armature is given as 30 centimeter, right? 30 centimeter. So now the motor is drawing 25 ampere current. Motor is drawing 25 ampere current, right? So this current is 25 ampere. So that is a current drawn by the motor, right? Now it is running at 1500 rpm. So operating speed is 1500 revolutions per minute, that is rpm. Now we will have to calculate the torque developed. So torque developed, we know the relation T, torque T is equal to Ka phi Ia, right? Ka is Pz by 2 pi A, into flux in the machine into armature current, right? So that is the formula that basically we have derived. Please do watch my earlier videos on the derivation of these formulas on DC machines. So if in this equation, let us call this equation is equation number 1. This is equation number 1. So if we know all these values, that means number of poles, number of armature conductors, number of parallel path, flux and armature current, then we can calculate the torque developed, right? So the same we are going to do. Now in this formula, I know each and everything. I know the current, I know the armature conductors, I know the number of poles, I know the parallel paths, I know the value of 2 pi, but I do not know this flux. Flux is not known to us. So for the calculation of the flux, he has given these data, length and the diameter, right? So here area per pole we need to find out, right? First of all, we should know that flux is phi, it is nothing but flux density B into area, right? Area. So now area per pole is area per pole is equal to pi dl by P. So for whole periphery of armature, that is pi d, P number of poles are accommodated. So the total peripheral area becomes pi d into length of the armature. So pi dl by P will be the area per pole, right? So now put all the values. Pi is 3.14, d is given as 30 centimeter. So 30 into 10 to power minus 2 meters, right, into L. L is given as 20 centimeter. So write 20 into 10 to power minus 2, and that is whole divided by number of poles, that is 4. So when I solve this, I will get 0.0471 meter square, right? So you have to use a calculator to solve this value. So 0.0471 will be the area per pole, right? So now I can easily find out the flux because I have calculated the area. So flux will be flux density B, that is 0.4 Tesla, right? And area is 0.0471, just now we have calculated, right? So 0.4 into 0.0471 will be the flux, and that will be equal to 0.01884. Unit is Weber. So that is a flux. So now we have calculated all the values. Flux was unknown to us, flux was not known to us, flux we have calculated now. So now put all these values in this equation number 1 and calculate the values of torque that we have to find out in this particular numerical. So from here I can calculate the torque developed. So you know that it is a lap connected machine, so number of poles is equal to number of parallel paths, A is equal to P. So P gets cancelled with A, so torque will become Z by 2 pi, right, from equation number 1. T is equal to Z by 2 pi, P and A are equal, so they get cancelled. So Z by 2 pi into phi into IA. Now no information is given about the field current and the field resistance. So the same current, the given current, you have to take as armature current, right? So the line current will be same as armature current, right? Almost. So IL is equal to 25 ampere. The line current is equal to armature current, 25 ampere. So just put all these values. So Z is 400 divided by 2 pi, 2 into 3.14, right? So flux phi you have calculated 0.0188 and 4 into this current, armature current, that is 25 ampere, and that comes out to be equal to 30 Newton meter. So that is the answer, right? So here motor type is not given, whether it is series or shunt, right? And no information is given about the field resistance or field current. So just take the given current as armature current and use this current in this torque formula to calculate the value of developed torque, right? So torque will come out to be equal to 30 Newton meter. So option A is correct. Option A is correct. Option A is correct, right? 30 Newton meter is the answer. Thank you very much. For all such kind of exam oriented questions, do subscribe this channel. Thank you very much. Thanks for watching.